Okay. So let's start this here. And do you have assignment 3 in the practice set? You do? Cool. All right. So what I'm going to do, because we were supposed to cover 3.4 on Monday, but we didn't. So if you don't have these notes, the 3.4 notes, if you got the new chapter 3 printout, they'll be in there. So just flip through and see if you have the 3.4 notes. If you don't, just come grab it after class. Today we'll go through the practice test. What you probably noticed if you had a look is that 11 is 3.4. So what I want to do for you guys is I'm going to keep it on the test, but as a bonus question. Okay, so it's going to be, it was 6 points, so it's 6 marks out of, I think, 10, 15, how many? 47, so 41. So it'll now be out of 41, but you'll have those 6 marks available as bonus marks. Okay? And so it'll be there. I think I did the calculation, so you could potentially get 115% on this test. I think that's, well, kind of fun, right? It does mean that you have to learn it on your own, right? You have the notes, and actually there's a recording of the lecture that I did in the afternoon where I cover it. Okay? And so there is a recording of it, just not me with you guys, me with others. Okay? So, yeah, I'll just write that all down here. Oops, what's that? 121. So, we have not covered 3.4, which is the binomial, in class, but I will keep it on test 1 as a bonus question for 6 marks. So if you don't want to go into it and you don't want to learn it, then fine. You don't get those bonus marks. It doesn't hurt you at all, right? But if you do want to put in a little bit of effort and learn that stuff, then you got it. Some resources are going to be the 3.4 notes, of course, and also the Stat 124 February 4th video. And I'll also post the notes. We'll post these notes on Moodle. Just so you know what's going on there. Okay. We also, I think we didn't quite get a chance to finish working backwards with the Z-score. I can't quite remember. So those will be in those notes as well, and we'll do it in the practice test here. So I'll just show you through the practice test. Okay, so for assignment 3, question 3, I think. question 3. Question 3 is the binomial. And it won't be for marks. So for the assignment, because it's due on the same day as the test, you can do it for practice, right? So not for marks. Can use as practice. And because the assignment is due on the same day as the test, right? Absolutely ask me questions, but what you'll notice is that the practice test has the same layout as the assignment, and so you'll be able to kind of put things together that way. But absolutely, you can ask me questions about the assignment. Ask me, am I on the right track here, if you're not sure, right? And so just ask questions about the assignment, make sure it's all under control. Okay. So, number 3, just don't do it on the assignment. You can do it for practice, but I won't be marking it just because I'll be marking the test. Okay, let's see here. Also, question 11 on the practice test is the binomial. So you'll want to make sure that you have those notes, the 3.4 notes. If not, come grab them after, in case you want to go through. Yeah.
So because you're making the binomial and a bonus question, are you adding another long answer question? It's just going to be 2.
Yeah. So it'll just be 2 real ones now. Gives you time to work through the binomial if you decide to try. Which I think you should. It's worth a shot, right? So, all right. Any other questions? Oh, okay. So, let's see here. Everyone has a copy of the practice test? If you're missing a copy, come grab one here. I'll just write it on here. Practice test number 1, solutions. Oh, I'll just kind of copy these chunks in here. Oh, yeah, that works. So first, I've just given you a list of potential multiple choice things that I could ask you about, right? So if I give you a bunch of data, right, or a summary of a data set, for example, and then I expect you to be able to look at those variables and those descriptions of those variables to decide whether things are categorical or numerical, and which one's the response variable and which one's the explanatory variables if I give you a research question. Right? So that's kind of going way back. Right? Data collection, kind of vague, but what we landed on was that everything just has to be randomly selected, right? So at its core, everything has to be randomly selected. For the visualization, right, that'll depend on what you decided this variable was, right? So if you've decided that this is a categorical variable, then to visualize it, you should use a bar graph. If you've decided this is a numerical variable, then you should use a histogram, right, to visualize it. Describing the center and spread of distributions, right? So for a normal distribution, we use the mean and the standard deviation. And for anything that's clearly skewed, right, we have to use the median and the interquartile range. Calculate the standard deviation. It's going to be for like 4 points. So nothing crazy, just show me that you can do it, right? And so 4 or 5 points. So not like those big ones that you did on assignment 1, right? I think, how many points were there? 9 or 10? Yeah. Ugh. Just do a quick and dirty one, 4 points or so. I'll give you data and you'll have to find the 5-number summary. How that's going to go in a multiple choice situation, right, is that I'll just ask you, so here's a set of numbers, just like on assignment 1. You make your 5-number summary, and then the options will be Q1 is this, Q1 is this, Q1 is this, Q1 is this. You just pick the right Q1, right? And there might be 1 or 2 questions from that 5-number summary. Okay. Same thing, the 1.5 IQR rule for outliers. Just use the 1.5 IQR rule to find if there's outliers. So you have to find the lower bound and the upper bound. If there are values outside those bounds, you have outliers. Right? You can do this just using a 5-number summary, right? For example, so practice doing it with just the 5-number summary. How can you do that? Like in the 5-number summary, right, you've got the quartiles and the min and the max. If your lower bound is less than the minimum, you have no outliers, right? If your upper bound is greater than your maximum, you have no outliers. If your lower bound and your upper bound are closer to the median than the min and the max, right, kind of inside, then you have data outside. Right? And then given the 5-number summary, pick a box plot. So given the 5-number summary, so a box plot has the median in the center, right? And then the quartiles make up the rest of the box. And then it goes to the min and the max, right? Or to the values inside the lower and the upper bound. And then outliers are denoted by stars. And then here, I had a little bit of I got my trees and my stem and leaves. It's the leaves and the trees coming mixed up. So this should be stem and leaf plot, which makes that question on the practice test kind of tricky. Let's see what I mean. Okay. Any questions about that? Okay. So that's going to be 10 multiple choice. Okay. From chapter 2, we'll have 15 multiple choice. First, I'm going to test things, theory things. So what does it mean to be disjoint? It means that no outcomes can happen at the same time. Right? What's the sample space? The sample space is the set of all possible outcomes. Remember when we went through and I gave you, we had 3 probability distributions and we have to decide which one's valid, right? And so we had to check, okay, are all the probabilities between 0 and 1? If there's one where that's not true, right, it's out, it's not valid. And is the sum of the probabilities, is it 1? If it's not 1, it's out, right? So you have to check, are all the probabilities between 0 and 1, and do they add to 1? And also, all the outcomes have to be disjoint, but they will be. Okay? So the general addition rule is the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Right? That's on your formula sheet. There's just going to be a question asking you to use that formula. I'll give you fresh ones. Yeah, so you'll have to use my formula sheets, but they'll look the same. So you'll know what to expect. I might add more stuff for the stuff that we haven't covered, just so we have it for later on. So it might look a little different, but the first part that we're working in will stay the same. The general multiplication rule we have on your formula sheet, sort of. It's the probability of A and B is the probability of A given B times the probability of B. And that's from conditional probabilities. So I'll jump down to conditional probabilities that say if the probability of A given B is the probability of A and B over the probability of B. So the probability of A and B, if we have to solve for it in general, right, we just multiply both sides by the probability of B, and that's how we end up with this general multiplication rule. Okay. The complement of an event is just the opposite of it in terms of probabilities. The probability of the complement of A is 1 minus the probability of A. So you're just using these formulas to answer questions. Independence, you have on your formula sheets, if A and B are independent, then the probability of A and B is the probability of A times the probability of B. Sneak that on there. And then find probabilities using a contingency table or probability table. We'll go through an example. Any questions about that? Yeah. Oh, I have them here. So just come grab them after class. Thank you. Oops. I know who's at the back. Jared. I ripped your page. I'm sorry. And everyone saw it. Oh, here, I got sloppy. The probability of A times the probability of B. Is that better? Yeah. So just multiple choice questions asking you all these probability questions. Okay. So for the long answers, right, we'll just go through those. What I want to do is work through all these. So, and I kind of want to start with the long answers. How do we feel about that? Long answers? Let's start there. I made these probabilities up, so don't put any money on it or anything. So let's say, so the probability of a clear day at Big White is 0.55, right? So 55% chance. And oh, which one? The handouts? All the handouts. How about, did you get the full chapter 3? Or do you have the start of those ones? Here. Assignment 3, practice stuff. So the probability of a clear day is 0.55. So assume that if the weather was clear the previous day, the probability of a clear day is 0.7 now. And so a little bit sneaky. If the weather is not clear the previous day, the probability of a clear day is 0.35. You're going skiing for 2 days. Okay, sounds familiar. Day 1, day 2. Okay. Build a tree diagram, and here I actually mean tree diagram. Labeling all the appropriate probabilities, including the probabilities at the end of each branch. Okay. So first thing we're going to do for part A is I'll let C be a clear day. Okay. So I go out on day 1, and it's either clear or not clear. And we said the probability of a clear day is 0.55, making the probability that it's not clear 1 minus that, so 0.45. So then we kind of branch off here, right? So assume that if the weather was clear the previous day, the probability of a clear day is 0.7 now. So now, off of this clear day branch, we're going on to day 2. It's either clear or not clear again. And it's clear with a probability of 0.7, so then it's not clear with a probability of 0.3. And then same thing here, just different probabilities. If it wasn't clear on the first day, it's clear or not clear on the second day. With a probability, so if the weather is not clear the previous day, the probability of a clear day is 0.35. So 0.35 and 0.65. So here, at the end of each branch, here we have a clear day and a clear day. Here we have a clear day and then not a clear day. Here we have not a clear day, but then we get a clear day. And then here we have 2 bad days. Yikes. So the probabilities at the end of each, right? So the probability of a clear day and a clear day is 0.55 times 0.7. 0.385. The probability of a clear day and then not a clear day, remember we just multiplied down the branches, is 0.55 times 0.3. 0.165. The probability of not clear and then clear, it's going to be different this time, right? Because it changed depending on if it was clear the first day or not. So it's going to be 0.45 times 0.35. 0.1575. And then the probability of it not clear is 0.45 times 0.65. Oops. Which is 0.2925. And just as a quick check, this is more to check that you have calculated these correctly, right? Because across here, these are all the possible outcomes that you can have, and so the total probability has to be 1. So if you add these probabilities up, they have to add to 1 if you've done your calculations correctly. So 0.2925 plus 0.1575 plus 1, or 0.165 plus 0.385 is 1. Phew. Okay. So now you know all these probabilities. Part B, just have a look on here. What's the probability that you have a clear day on both days? Now we can just steal this information from the tree diagram that we built. Okay. And so the probability of a clear day on both days is the probability of C and C, which we decided was 0.3, oh, of course, 85. So on the test, the tree diagram will be worth more than the other answers. I think we said 8 points. I think this one would be worth 4 marks, 1 mark, 1 mark, 2 marks. Yeah. Nah, you don't have to. Not for this stuff. You can if you want to be proper. But even I don't. Even I don't do it, as you can see. So then C, what's the probability that you don't get a clear day? You don't get a clear day on either of the days. That's a weird question. You don't get a clear day. I feel like what I meant to say, I'll make sure I don't have a word puzzle like that. I feel like all I meant to say was this. But technically what I'm saying when I'm saying either of the days is any of the ones without a clear day. We'll stick to not C, not C. Confusing. Don't worry. I put more thought into the test than the practice tests. So not clear, 0.2925. D, the probability of at least 1 clear day now we have those multiple scenarios, right, where CC, that's 2 clear days, so that satisfies C, not C, that's still 1 clear day, and then not C, C is still 1 clear day, and so all those satisfy. So that's going to be the probability of CC plus the probability of C, not C, plus the probability of not C, C. Which is also, if you wanted to, 1 minus the probability of not C, not C. In the end, you'll find that they both equal 1 minus 0.29. 0.7075. So you have two options for answering that one. Whether you like to add up those probabilities that satisfy the criteria or just subtract the one that doesn't satisfy it, that's fine. Any questions about that one? Okay. Steal this one. So now we're on to a long answer question using the normal distribution. So whenever you have to use the normal distribution, it'll be something follows a normal distribution with a mean this and a standard deviation of this. Right? So same sort of sentence structure over and over again. Oh, and I'll keep the order the same for the test, just so you know what to expect. Manatees travel at a speed that's approximately normally distributed with a mean of 3.8 miles per hour and a standard deviation of 1.3 miles per hour. Hey, what proportion of manatees travel faster than 4.7 miles per hour? Okay. So we can start with our normal distribution because we know the speeds follow a normal distribution with a mean of 3.8 and a standard deviation of 1.34. For this question, we want to know what proportion of manatees travel faster than 4.7. So 4.7 would be somewhere above 3.8 because we've just got a number line on the bottom. Right? So 4.7, oh, clean this up. And we want to know what proportion of manatees travel faster than this. Proportions, probabilities, percentages, those are all areas under the curve. So, to find areas under the curve, right, we have to use the Z table. And so first we need to find a Z score. So Z score, Z is X minus mu over sigma. X will always be the value that you're interested in. Right? So X is always going to be this 4.7 or whatever value you want to find a probability associated with. So in this case, we have 4.7 minus 3.8 over 1.34. 4.7 minus 3.8, 0.9 over 1.34. 0.6716411791. Z scores have to get rounded to 2 decimal places. Okay? And that's because the Z table only has 2 decimal places. So 0.67. Z must be rounded to 2 decimal places. Oops. So now you can go to your Z table, or I guess I have one on here, I think. So we've got a positive Z score, and our whole number is 0 and 0.6. We have to join it up with 7, so 0.67. The area to the left, right? This table only gives you the area to the left is 0.7486. So we're going to write that out exactly what we did. So using the Z table, we find the area to the left of Z equal to 0.67 is 0.7486, is that what it was? We don't want the area to the left, right? But the table always just gives you the area to the left, and then you have to know if you want the area to the right. So therefore, knowing that the total area is 1, right, we also know the area to the right. Therefore, the area to the right of points, or Z equal to 0.67 is 1 minus 0.7486 0.2514. Yeah, you can. If you wanted to use the symmetry, right, you would look up negative 0.67, right, and that would just give you the area to the left of negative 0.67, but then by symmetry, that'll be the same as the area to the right of positive 0.67. I'll always just kind of go this way, but if you've got that symmetry under control, then that's a little bit easier. Instead of writing this out, you could have said the probability that Z is less than or equal to 0.67 is 0.7486. So that's an alternative way that you could write out that sentence. And the probability that Z is greater than or equal to 0.67 is 1 minus 0.7486, which is 0.2514. So if you prefer to use the probability notation, then that's fine. Otherwise, I want you to write out that little sentence telling me exactly what you did. So 0.2514 of manatees. That doesn't really make sense, does it? .2514 is the proportion of manatees who travel faster than 4.7 miles per hour. Who travel faster than 4.7 miles per hour. B is similar, right? Now we want to know what's the probability of a manatee that travels slower than 1 mile per hour. So we've got the same kind of situation here. Got a normal distribution still, and it's centered on 3.8, and sigma is still 1.34. But now we're down here at 1 mile per hour, and we want to know what's the probability of finding one that's slower than that. So again, we have to calculate the Z score. Z is X minus mu over sigma. 1 minus 3.8 over 1.34 negative 2.0895522239, which is approximately, right, rounding to 2 decimal places again, negative 2.09 to 2 decimal places. So now, going to your table, right now we're on the negative z side. So negative 2.09, so we have to go to negative 2.0. And then 9 is the last one, 0.0183. So again, I'm just going to write out exactly what I did. So using the Z table, we find the area to the left of Z equal to negative 2.09 is 0.0183. So short-term memory. Or if you wanted to use probability notation, the probability that Z is less than or equal to negative 2.09 is 0.0183. So you don't have to do both. I'm just showing you both ways. Therefore, the probability of a manatee that travels slower than 1 mile per hour is 0.0183, because that is the area that we wanted. Any questions about that one? Oh. Okay. C. This is the part that we didn't quite get to finish. I am pretty sure. Was a while ago though, so I don't really remember where we ended. So I'll take my time kind of explaining this one as I go. But all we're doing is just working backwards now, right? So now I'm giving you this area under the curve, and you have to work to find the cutoff that makes that happen. So you'll start the same way. You'll start with your normal distribution, and the center is still 3.8, and the sigma is still 1.34. But now we want to know, how slow do the slowest 15% of West Indian manatees travel? So now we're forcing this area to be 0.15 or 15%. But when I talk about those areas, I want to talk in decimals. Right? So now what I'm looking for is this little guy. So before we had this guy, and we turned it into a z-score, and then we use that z-score to find this area. Now we're just going to backtrack. Right now we have this area. We can go into the z table to find this area, find the z that it matches up with, and then we can solve for x. Right? So before, I think I did this before, but we were finding x, and then z, and then a probability. We went from x to z using z is x minus mu over sigma. And then from z to a probability using the z table. Now, all we're going to do is we're going to reverse this. now we've got a probability. We find the z, and then we can solve for x, right? Because now if we have z, and we have mu, and we have sigma, then we can solve for x. So let's go in here. So 0.15, we know we're going to be on the negative side of the z table, right? Just because at the mean, we've got 0.5, right? Half of the distribution's below it, half of it's above it. So we know we're going to be on the negative side. So we can go to our table. And I'll show you this. These values are table entries, or they're called table entries. And so you'll see I didn't pull that out of nowhere. It's saying, okay, here's a table entry. That's the area under the curve. So what we can call these guys is table entries. And so what we're going to look for is we're going to look for a table entry that's closest to 0.15. It's not going to be bang on often, but we have to find the one that's closest. And so what we'll do here is we'll just kind of scan for something close. This looks good. Notice that they're increasing as you move across this way and then this way, just because of how numbers behave. But there is logic here. And so these two values seem to be the closest. So we've got a choice between 0.1492 and 0.1515. I always use my calculator. I don't do this in my head. But I kind of think of this as being 15 away from 0.15, right? And then I just have to do 0.15 minus this guy to see how far away it is. So 0.15 minus 0.14, what was it, 92, is 8 away, if that makes sense, right? Because you get 0.0008. So it turns out that this one's closest, right? However you want to find the closest one is fine. In fact, if you wanted to tell me that you're going to use this one, I'll take half a mark off. Just, I'll consider it a typo, right? But then if you follow through with the wrong one, it doesn't hurt you. Okay? So what are we doing here in words, you ask? So again, using the Z table, we find the table entry closest to 0.15. We find the table entry closest to 0.15 is 0.1492. Which corresponds to Z equal to, so now I'll go back here. Oops. Corresponds to a Z of negative 1.04. Back there. Negative 1.04. Okay. So now we know what Z is. Z is x minus mu over sigma. We know mu and we know sigma, so now we can solve for x. So Z, you're forcing it to be negative 1.04, is x minus mu, which was 3.8, over sigma, which was 1.34. Solving for x, we've got 1.04 negative times 1.34 is negative 2.38, is x minus 3.8, so add 3.8 to both sides. So x is 1.42. On your formula sheet, you have x is mu plus z sigma. So if you wanted to go to that one instead, that's fine. What you'll find is that mu is 3.8 plus z, which was negative 1.04 times 1.34 is 1.42. So you'll get the same answer. I like to solve for things. I just like having one formula and then I solve for whatever I need. So I don't actually use that x formula. It's just z rearranged.
The second equation doesn't make 1.42, it makes 2.41.
Oh, did I really? Let's see here. 1.04 negative times 1.34. 0.8. Oh, you're so right. Keeping me honest up here. 2.4064. So I must have done the other one wrong too. 1.04 negative times 1.34 plus 3.8. Yeah. Oops. Thanks, guys. 2.4064. Okay.
Is sig figs the final answer or something?
Nah. Oh, yeah. 4 times 1.34. 1.3936. Fixed part, but not all of it. There. I don't care about sig figs. So I would keep all these decimal places. So for me, keep as many decimal places as you can. So keep as many decimals as you can. As long as you've shown me your work, if you ended up rounding, right, unless I specify, give me 3 decimal places, right, and you don't follow that instruction, then that's not good, right? But if you just shown me what you did and then you round, then I'm okay with that. Okay.
So we can use either equation.
Yeah, whichever one you like better. Yeah, in section 3.1 on the formula sheet. Okay. So now, any questions about that one? Now that I've fixed it. Otherwise it was confusing. D. Again, we start with this normal distribution centered on 3.8 and sigma is 1.34. What speeds capture the central 90%? So now we want to know two values here, and we're forcing this area to be 0.9. Same situation, right? We've got the area under the curve that we know, and we want to solve for what values cut this off. What's nice is that if this is a central 90%, then the area in the tails here is going to be the same. Right? We've got 0.1 left over, split evenly amongst the two tails. So that means that we have 0.05 here and 0.05 here. So this is just going to be the negative Z value, but this is going to be the positive of the same Z, right, as of symmetry. So what we've got here, we've got 0.05 and 0.05. So what we're going to do is we have to find our Z score, right? And so we're going to backtrack, find the area closest to 0.05, and find the Z score that corresponds to that. Okay. So using the Z table, we find the table entry closest to 0.05 is, oops. Let's see, oh, keep going to that one there. 0.05. Careful that you have the right number of decimals, right, for zeros, because it's easy to get caught up in something like this here, 0.0005, but that's not the number you're looking for. So you want to be somewhere down here, so between 0.0505 and 0.0495. See, that's an even split, so it doesn't matter which one you use. Write that down. Is either 0.0505 or 0.0495. You're just going to tell me which one you're using. If this happens, right, you would just tell me which one you're going to use. I will use, I don't know, 0.0505. But you could just as well use 0.0495, doesn't matter. Which corresponds to Z is, I don't know. So 0.0505, that's the one we landed on, right? And then we have negative 1.64 or negative 1.65 if you picked 0.0495. Negative 1.64. There. So now Z is x minus mu over sigma, or if you prefer to use x, is mu plus Z sigma. That's fine too. But I like to use the original. Negative 1.64 is x, which we're trying to solve for, minus 3.8 over 1.34. 1.64 negative times 1.34 plus 3.8. I get an x of 1.6024. But if you guys can double check it. So what we've done, right, is that we found that this cutoff here is 1.604 miles per hour. So now we have this cutoff. Now we just need to find this cutoff. What we can do is, well, yeah, you could go ahead and find 0.95, right? The z squared closest to 0.95, because that would be the area below it, right? Or you can just say, okay, well, by symmetry, right, if this was negative 1.64, then this must be a z of 1.64, the positive version, right, just by symmetry. By symmetry, we know z equal to 1.64 is the cutoff on the upper end. So again, z is x minus mu over sigma. And so now we have 1.64 positive is x minus 3.8 over 1.34. 1.64 times 1.34 plus 3.8. I get an x of 5.9976. Oops. Therefore, the central 90% of speeds are between 1.6024 miles per hour and 5.9976 miles per hour. Okay. I wonder if we should go through the multiple choice practice number 8. Just with the time that we have left. I'll post the solutions to all of them, of course, but just so we can go through this one together. Just because 11 is that bonus question, so you'll have the solutions, but if people are deciding to not do it at all, then I don't want to spend time going through it. So this is one of those contingency tables, right, or probability tables. And so the American Community Survey is an ongoing survey that provides data every year to give communities the current information they need to plan investments and services, blah, blah, blah. So the 2010 American Community Survey estimates that 14.6% of Americans live below the poverty line, and they had defined the poverty line, but I cut it. 20.7% speak a language other than English, so a foreign language at home, and 4.2% fall into both categories. So what I've done is I've set up this table. And I'll do this on the test too. And what you'll do is you'll fill in the values. And so we know the total here has to be 1. Right? And this plus this has to equal this. this plus this has to equal this, but also this plus this has to equal 1, and this plus this has to equal 1. So you can use those facts to fill in the table. So we can start with the top line and say, okay, well, if those two have to add to 0.146, then I can just subtract 0.042, and then I have 0.104 here. Knowing that the probability down here in the corner has to be 1, then I can say, okay, well, 1 minus 0.146. So this area has to be 0.854. Probability, rather. Same thing for the other marginal. 1 minus 0.207, 0.793. I know that 0.042 plus whatever has to equal 0.207. So it has to be 0.165. And then 0.165, so 0.854 minus 0.165, 0.689. So filling out that table, just keeping in mind, right, that those lines and the columns have to add to whatever is at the end of the line or the column, and the margins have to add to 1. A, are living below the poverty line and speaking a foreign language at home disjoint? They're not disjoint, right, because there is a probability of them happening at the same time. No, they are not disjoint. Because there is a 0.042 probability they will happen at the same time. Ah. Thank you. Yeah, that would have gotten confusing. Oh yeah, A, fill in the missing probabilities. Did it. C then. What proportion of Americans live below the poverty line or speak a foreign language at home? So they have to live below the poverty line or speak a foreign language at home. So we've got a few options here. You can use the formula, which is what I'm going to do. So first I'm going to let F be speaking a foreign language at home. And P be living below the poverty line. And we want to know the probability, right, which is a proportion of Americans live below the poverty line or speak a foreign language at home. So the probability of P or F is the probability of P plus the probability of F minus the probability of P and F. From your table, the probability of P below the poverty line is 0.146, right? It doesn't matter if they speak a foreign language at home, right? 0.146. And the probability of F is 0.207. 0.146. Messing up numbers all over the place here. And 0.207. Subtracting that overlap of probability, living below the poverty line and speaking a foreign language at home, which is 0.042. So we get 0.146 plus 0.207 minus 0.042, which is 0.311. I'd say that's the easiest way to find the solution just because it has the formula, but however you want to find it, if you want to use the tables and kind of match up and add up probabilities, that works too. D. What proportion of Americans live below the poverty line or live above the poverty line and speak English at home? So not P and not F. I'd say the easiest way to find this is just to look at the table. So they have to live above the poverty line, so they have to be in this, on this line here, and speak English at home. So the only one that satisfies that is 0.69. So like I said, I'll post all these solutions for you guys. Come grab your assignment too. They're sorted alphabetically by last name. I'll just put them here. Let me know if you have any questions.